today we are looking at the inverses of log and exponential functions. Now remember, logs and exponentials are inverses of each other. So if I am taking the inverse of an exponential, I'm going to end up with a log equation. And if I'm taking the inverse of a log, I'm going to end up with an exponential equation. So in case you've forgotten, because it's been a while since we have found inverses, you are going to switch x and y, use algebra to solve for y, and then remember we use that f to the negative 1 notation to represent an inverse. So we're going to jump into an example here on A. Remember this function notation could be replaced with y. So y equals 3 times 2 to the x plus 4 minus 15. So I'm going to switch x and y in that equation, and I am now trying to get y by itself. So the first thing I'm going to do is add 15. Then I am going to divide by 3. And now I'm left with an exponential and y is in my exponent. So to get it out of the exponent, I need to rewrite this as a log. So that's going to be log base 2 of this whole thing, x plus 15 over 3, and that's going to be equal to y plus 4. So the last thing I'm going to do here is subtract 4. So y will be equal to log base 2 of x plus 15 over 3 minus 4. And then writing that in our function notation, f to the negative 1 of x is equal to log base 2 of x plus 15 over 3 minus 4. Moving on to b, again I'm switching my x and my y, so x is going to be equal to 3 to the y plus 1 minus 2. So I'm going to add 2 to both sides. Now my exponential is by itself, so I'm going to rewrite it as a log. This will be log base 3 of x plus 2 equals y plus 1. So my last step is going to be to subtract that 1. And in function notation, this will be h to the negative 1 of x equals log base 3 of x plus 2 minus 1. Moving on to C, this time I have a log equation. So again, switching my x's and my y's, and started writing and talking at the same time and got switched around. So x equals negative 3 log base 5 of y minus 4 plus 6. So 6 is going to leave the party first by subtraction. Then I am going to divide by negative 3. And now my log is by itself. I need to get y out of the log, and I'm going to do that by rewriting this as an exponential. So 5 to the x minus 6 over negative 3 power is equal to y minus 4. So my last step is going to be to add that 4 to the other side. And I'm going to put this exponent in parentheses because it's kind of complicated. And so there's my inverse, putting it in inverse notation. G to the negative 1 of x will be 5 to the x minus 6 over negative 3 power plus 4. Okay, last one on D. I'm going to switch x and y again. So x equals negative natural log of y plus 3 plus 7. So to get y by itself, first I'm going to subtract that 7. Then I'm going to be dividing by negative 1, so that is going to switch the sign of the x and the 7. Now my log is by itself, so I can rewrite this as an exponential. The base for natural log is e, so this is e to the negative x plus 7 power equals y plus 3. My last step is going to be to subtract that 3 there. And in function notation, j to the negative 1 of x equals e to the negative x plus 7 minus 3. And then our last example here is, if this is my function for k, what values of x does k to the negative 1 equal 1? Now remember, this notation means inverse. So the first thing I'm going to do here is find the inverse of k. So x will be equal to 3 to the y minus 2 power minus 9. I can add 9, then rewrite this as a log. Then add 2, And so my inverse, k to the negative 1 of x, is log base 3 of x plus 9 plus 2. Just partition that off so we know it's separated. So to find what x values make this 1, I'm going to set the equation equal to 1 and solve for x. And this is just a log equation, which we know how to solve. I'm first going to subtract 2. And then I'm going to rewrite this in exponential form. This will be 3 to the negative 1 equals x plus 9. 3 to the negative 1 is 1/3. So if I subtract 9 on both sides, that's going to be 1/3 minus 9 with a denominator 3 is 27 over 3. So x is negative 26 over 3. And that concludes our notes today.